Assalamu alaikum, wonderful people. In today's lesson, we would be covering the d-Subshell orbitals. If you want to know about the s and the p orbitals, well, I've already made a video on those. I'll put the link in the description box. Today, we will be covering solely the d-Subshell orbitals. Let's begin. So, the first thing that you need to know about the d-Subshell orbitals is that we have 5 orbitals in the d-Subshell. And when I say 5 orbitals, I mean 5 possible orientations in 3 dimension. Other than that, we know that one orbital can hold about 2 electrons. So if I'm discussing 5 orbitals of the d-Subshell, what do we have? We have 10 electrons. So maximum number of electrons in the d-Subshell which are possible are 10, and each one of those will hold 2. And well, let's get into it. Now, first of all, I will mention over here basically the name of the orbital, and then we can sketch it. So let's first make dxy subshell. Okay, so d is the subshell name and or the shape name, and x and y is basically the orientations. Now let's label our axes. So let me label this as the x-axis, this as the y-axis, and this as the z-axis. You can even make this as the y-axis and this as the z-axis. It doesn't really matter. All that matters is that you're sketching it in the right way. Now, what do we mean by dxy? So when you read xy, what that basically means is that generally a d-Subshell orbitals have 2 lobes. So that's actually a horrible lobe. But one lobe like that, and then maybe another one like that. Now, the way that we position these 2 lobes depends on what information is present right here. Now, what x and y means is that these 2 lobes will be placed in between the x-axis, and the y-axis. All right, so it's basically going to be passing through the xy plane. This place right here will be passing through the xy plane from here. So let me sketch that for you guys. So first of all, here's my y-axis and here's my x-axis, and just for the convenience, I'll also mention it here. This is my x-axis, y-axis, and z-axis. Now, so we have a lobe which is going to be between the x and y. So here's the y and here's the x. So the first lobe is going to be positioned in this way. Okay. Now the second lobe is going to be again positioned in the xy plane. But once I'm done with this orientation, okay, I will look at this orientation. So x and y. So between this x and y. And the second lobe will come somewhere over here. Okay, now this is a horrible lobes. I'm not that great at drawing lobes, but you get the general idea. What the examiner is looking for is if you can identify the orientation given here and then make it or draw it in the respective, in keeping in mind wherever this x or this y or this z is, just keeping in mind the concept that if you see an xy, that means you locate the x, you locate the y, and then in between you draw the lobe. Again, locate the x, locate the y, and you draw the lobe. Now notice something over here. Notice that one of the lobes is simply passing through x and y in between of x and y plane, and the other lobe that we draw, which is also passing between x and y, is there's the z-axis. We've drawn it in such a way that it seems as if the z-axis is going through it. So in this case, one lobe is not being intersected by any line, but over here the other lobe is being intersected by the third axis, which is not mentioned over here. And this will get clearer as we go on. So this is your dxy. Now how about we draw the dyz? Okay. And again, what does this yz state? It tells make 2 lobes and make sure they are between the y-axis and the z-axis. So again, let's label. So this can be my x, my y, my z. Again, let me mention that here. Now, so here's my y and here's my z. So there should be a lobe in between these two. So it's going to go between these two. And then you can see my other one is that this is my z and this is my y. And then this is my z and this is my y. So the lobe goes like that. Okay. And in this case, it's actually again not is super nice. It's not super nice. Let me draw that again. I can actually draw it much better. It's one of the things that used to give me anxiety, making sure that these lobes are perfect. Well, there you go. And if I had drawn it much more neatly, you would have still noticed that again, you have the y-axis, you have the z-axis, and you have a lobe in between these two. And then you also have this y and z, so there's another y and z, in between space. But in this case, it's going, this one lobe, single lobe, will be passing through the x-axis, so it will be intercepted by the x-axis. So now let's move on. Now let's do the d x z lobe. So here's the x, y, z, x, y, and z. Now let's draw this. Now here's my x and here's my z. Here's my x and here's my z. So one of the in-between spaces that I see is this, right? So one of the lobes will come over here like that. Horrible. All right, one of the lobes comes here. And another, if you notice, another space between them is this. This is also another space between the x and the y axes. So the other lobe is going to go over here. And again, if you notice, here's one space, all right? And the second lobe is passing through, it's also between x and z axis, but it's passing through the third axis, which we did not include. In this case, it's the y axis, right? Now, we have these three lobes are kind of similar in this manner, that what you get to see is that, okay, here's the xz. I will make two lobes between, xz. So here's one space, and then here's the other space. And what we notice is that one of the lobes passes through in this manner, and the other lobe, when it passes, the third axis, which we did not include, will intersect it or pass through the other lobe. Similar case with dyz. Okay, so we locate the y and the z, and here's one space which passes through unintersected, and then there's another space, but it is being intersected by the third axis, in this case the x-axis, which we did not include. And the same case is for the dxy. We locate the x and the y, we draw two lobes between them, and we notice that one of these two lobes will be intersected by the third axis, in this case the z-axis, which we did not include. Now, the other two are kind of different. The first one I'll talk about is the dx square y square. Okay, and this is located in this manner. So this is my x, y, z, x, y, z. First label your axes. Now what x square means is that make a lobe which is entirely on the x-axis in this manner. So this lobe is entirely on the x-axis, and make another lobe, which y square means make another lobe which is entirely on the y-axis in this manner. So this is your dx square y square. And if you notice, what's special about this orbital is that both of its lobes are being intersected by the axes that we mentioned here. So for x square, it passes through x square purely, and then y square, it passes through y square purely. So in this case, you don't see it being intersected by any other axes. The last one is kind of a beautiful one. It's dz square. Now again, let me label these. This is x, y, z, x, y, and z. Now in this case, what we get to see is that dz square, what that means is, well, again, make one lobe which is entirely on the z-axis. Now you would be thinking, how do I draw the second lobe? Now the second lobe becomes more of a donut, and that's basically, it goes around the z-axis. So in this case, I'll try to color it to make it distinct from the other one. But it more or less, I should actually erase that, because that gives you the image as if it's going on top of it. It goes behind it, right? I'll make a better one over here. It's more of a, it's like a donut, which is passing through a dumbbell. So I'll draw it here. What it looks like is, um, so let's say this is my x, this is my z, and this is my y. I'll I would change that so that you can draw it with other labels as well. So in this case, here's the single lobe which passes through, right, the z, and the other one will go around it. So it goes like this. All right, I hope that makes sense. I'll try to make this neater. So this right here, my friends, is your 5 of your orbitals for the d-Subshell, and all of this is in three-dimensional space. I've already mentioned that in one of my previous videos on orbitals, that do not consider these to be 2D shapes. These are not 2D shapes, rather they are 3D shapes, and they are such 3D shapes where the probability of finding an electron is maximum. Okay, and when you will go to higher levels and study about the wave mechanical model of atoms, you would understand that these orbitals are not in fact definite shapes. They don't actually definitely look like this, but rather they're just a it's just a expression based on probability, and that probability, there's uncertainty, that's why there's a probability, and that probability arises from the Heisenberg's uncertainty principle. You can go read it up, maybe read about wave functions and all of that, but for A levels, for this purpose, at this level, all you need to know is about the shapes. I hope you guys found this video helpful. If you did, do give it a thumbs up and leave a comment down below for any topics that you would want me to cover, and do not forget to subscribe. Khuda Hafiz.